Hi, I'm Maria, and I'm happy to be here to explain some things about data mining today. Now back to the roots, from metaverse to data mining and to the processes and also predictive analytics. I will speak a lot about the whole process, about stages inside of it, and explain an example of hospital stay prediction. It's just a use case, and the whole thing around it is more enterprise company processes that we are using inside of data mining projects. But first of all, I would kindly ask you to go to menti.com and put this code inside of it, because I would like to discuss one question with you. So we will check what you already know about.
That's a test.
Yeah, it is. Is there a price?
All of you are very concentrated, and I'm happy about it. Okay. So, I see some of you already wrote it.
No.
So we have this live show now. Yeah. So you missed something. You have to put your word. No? Okay. Yeah. Which of the following is not part of data mining? And as I see, most of you are not right, unfortunately. Because data archaeology is not a part of data mining. So maybe we can wait a second and then. Yeah, all three answers on the left, so data transformation, knowledge extraction, data exploration are parts of data mining, and data archaeology is like a fun point. Even then, if sometimes data mining feels like exactly like data archaeology, because you have to search a lot inside of data. So it was a little interaction warm-up for us, and now we will start with the topic itself. Thank you. Yeah, so we will start with the CRISP-DM. It is a cross-industry standard process for data mining, and it contains 6 stages. All of them are there, and I mean the names are self-explaining. And we will go deeper for each stage with the example. As you can see, maybe it's also important, some of the stages can be repeated. Yeah? There where you see this around, you can go, for example, back from data understanding back to the business understanding, and also you can change between modeling and data preparation. What is the challenge for us in our use case? So I got a data set from Kaggle with patient data, and my main purpose was to build a model to predict the duration of hospital stay for new patients for better resource management. All of us knew this use case from last years, but also besides this hard situation, it is every time very important for the hospitals to be able to plan. And today's is not every time possible, and maybe it's a good possibility to apply data mining and machine learning for such cases. A bit of context, I made this project or case study as a part of my professional training. I had some external restrictions and also restriction on my hardware. I will mention it, just keep it in mind, but yeah, it's not a problem right now, but on some other stages. Here we can have a deeply look at the data. It's a cut of input data. You can see there some columns like case ID, hospital region, and also, for example, the department of the hospital, which is relevant. And in total, I had a data set with about 318,000 of rows distributed over 70 columns. The last of them is the column named stay days, and it acts as target variable. At this stage, it is an indicator that it is about classification problem, because you have categories. For example, 0 to 10 days, from 11 to 20 days, it's categorical, and you try to solve the problem to assign each of these records to one of these categories, and it is typical description of classification problem. At this stage, I took a lot of time to understand the meaning of each column to be able to prepare my data for the training. And next stage is exactly this, data preparation. And very typical steps inside of preprocessing is, for example, trivial remove ID columns because they have no value for the model. But you have also more complex tasks, like found some solution for missing values, or also need some preparation for your models. For neural network, it's very important to transform the categorical values to the numerical ones. And for example, for decision tree, you have to do it vice versa. So you have to take data which are not discrete and make them discrete. It's called binning. So it's some techniques that you have to apply before you train. And next stage, it is the first training itself. For my use case, I choose two classical, typical models: is decision tree and artificial neural networks. Here, for example, maybe for artificial neural networks, I use different model architectures. For example, I used a single layer perceptron or multi-layer perceptron with a different distribution of number of neurons and also a different number of layers. So I could choose the best performance that it produced. And next slide will show you the first results. And it was 38% of accuracy, and the second only 40% of accuracy. And at this time point, I was really disappointed. So even I felt like this. I thought about what I could do to save the job. And then I decided to work on some possible optimizations, which I will present you now. I mean, every time there are a lot of roads that lead to Rome, and you can go different ways. Here I will show only a couple of them, and we will start with this one. So this diagram shows you the distribution of my data, and you can see they are very imbalanced. There are some categories, like for example, between 21 and 30 days, or between 11 and 20 days, they have a lot of data points, and the other classes are underrepresented. And it could lead to a problem, because the model can recognize and predict very well for overrepresented classes and unwell for the classes which are underrepresented. Likely, in data mining, there are some techniques that you can apply to solve this. And one of them is upsampling with so-called SMODE. It is synthetic minority oversampling technique. There are some points you have to think about. The recommended amount of data to fill up is about 10 and 25%. What you are actually doing? You take your data set and generate from this data set additional data and put it inside of the classes which are underrepresented. In this case, you have to think about, if you increase the amount of data, of course you need more runtime or more memory, depends, yeah, what you have. So, and in my case, it was not so easy to put just a lot of data, because I rather had a lot of time, and short term it was not possible to build up my hardware. That's why I combined two techniques. I combined smooth and downsampling. What I did, I applied smooth to the underrepresented classes and applied downsampling for the classes which were overrepresented. And you can see here on the right side, in the result data set, I had about 28,000 of data points for each category. And the results were like this. So the overall performance was slightly down, but the performance of previously underrepresented classes was increased, which could be beneficial for a lot of cases. So I can recommend it to apply these techniques, especially if you are not restricted by hardware. Go for it, and I think it can deliver very good results. And then I thought about what I can do else, and my hypothesis following to smart applying that for 11 target classes, the number of the data is overall not enough for the model. And that's why I decided to make another solution to reduce number of classes. This solution sometimes also you can find in the literature. Well, it's not applicable for every type of your problem. So in this case, you have to speak a lot with your business unit, with the people from the business, to understand exactly, can you apply it, does it bring something if you have only 3 classes at there. In my case, I think it could be still beneficial for hospital if they can have some prediction. It's better to predict in 3 classes than predict in 11, but very uncertain. And that's why I did this substitution. So the classes on the left side are substituted to the classes in the middle. And the results were very good for it. So the overall performance is increased from 38% to 73% by applying with decision trees. So, and I achieved my goal, and now I have some takeaways that I think could help. First of all, know your data. Yeah? I think it's not enough just to remove empty entries. You really have to have deeply look what are the columns. Do they have to be transformed? Otherwise, maybe you have a very good quality of data, but because you didn't take care of it, they produce still very bad or uncertain results. The other point is try out and compare, including evaluation. So every time build the metrics, compare them, and for example, I compared 2 types of models. There are much more. For example, you can take another class of models and also see if it delivers you the better results. As you saw, step back can be worth it. I went back from the modeling to the data preparation, and it delivered great result at the end. And last but not least, one of the most important thing, I think, even in the last step of CRISPR, it could be worthwhile to asking the initial requirements, and maybe even at the end make completely other solution. The main thing you provide benefit to the business or your use case. Yeah, that's all.
Okay, we now have have time again for a quick Q&A session. Are there any questions? Okay, first hand.
So I'm not a data professional, so I may say this wrong, but was part of the part of the analysis looking at, oh, if we remove this column entirely, do we get similar answers? So you determine, oh, this isn't even relevant really to our prediction? Like removing some of the inputs from the data to see if you still get the same level of accuracy by asking fewer questions?
Yeah, you can remove the data from the, so you can even remove the whole columns. For it, you can use, for example, like something like correlation metrics. There is another technique. You make this metrics, and you can see which columns have the most impact on the result. And if they are not so weightful, you can just remove them. And also, you mean this downsampling case that I remove the data, or I?
No, I'm more thinking in terms of just getting to a point of where you're asking the fewest questions that. Like, say, if you were surveying people to be able to predict how long they'd be in the hospital or something like that, maybe you can get it down. You can remove some questions off your survey or something like that. Like I said, I'm not a data professional, so removing features. Yeah, removing features.
Yeah, removing input features. You mean? Yeah, I answered. I think with this correlation metrics, it's possible.
Okay, yeah.
So if they are not impacting the results so much, then you can do it.
Okay, another question?
Yeah, you mentioned like if you had more hardware, you could do some other practices, but I was curious if you would take any different approach. If you had to approach this problem again, what would you do differently?
Complete from the beginning?
Yeah.
Yeah, I would probably, if I had more resources, I would follow this oversampling approach. I think according to optimization, even here you can see that the classes which has less data are also predicted further. So I think it's a huge potential here to increase the amount. So this is one point, and then maybe I would try another kind of networks, maybe naive-based, because it should perform also well on the less amount of data. And I would compare.
Okay, more questions?
Yeah, my question was mostly related to the last question. You said that you had some hardware restriction. So you tried to work with neural networks, basically, beside the decision tree. Maybe that doesn't help with iteration of testing new things. So why you didn't go with other naive-based algorithm or some XGBoost, which are faster to compute with respect to neural networks?
Yeah, so with naive Bayes, I mentioned it already. I probably would do it if I would have more time. And the other algorithms, I started with some bases, and at this point I didn't have maybe another experience, and I just want to have get feeling how it performs. And also I was really interested in the how the networks works and about the architectures. Is there some big difference depending on how many layers you take and so on?
Okay.
But I think, as I said, there are a lot of ways in the data mining. Yeah.
Thank you.
Okay, are there more questions? 3, 2, 1. Thank you. This brings to an end the official part of our meetup. Thank you all for coming. We appreciate you. Just a quick reminder that for the months of August we are taking a break, but then we're back on the first Wednesday of September with our Level Up meetups. We might do a social meetup in a bar, just without any speakers. if there is interest for it. Please let me know if you are interested. Just a reminder, stay tuned for our future events on Telegram and Meetup. We post everything there. We will be launching our new website close to our 5th level up meetup, so stay tuned for that. And I think there was something else that I wanted to mention. Oh yeah, thank you to our speakers. Thank you a lot to Commerce Tools for providing space for us and for their hospitality, in particular to Gloria and Nico. Gloria. Thank you to all for being awesome and being here. And now I think we are almost ready to enjoy the pizzas, but let's just wait for a minute until they're back. So yeah, okay, thank you.
Thank you for organizing.
Yeah, thank you.
Oh, yeah, good job.
I would say I'm not here yet. I'm not here. But basically, like, since my